Hello, my name is Evie, and I'm a second-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about inclined planes and screws, and I have HelperBot here who knows a lot about these simple machines to help out. We're going to focus on 2 of the 6 simple machines today, the inclined plane and the screw. These 2 simple machines are more connected than you might think. But first, a quick review. Inclined planes can be used for many things, like wheelchair ramps or in parking garages to lead to different levels. They make it easier to move things up and down, whether it's yourself, a car, a crate, or more. Carrying something heavy up a ramp is much easier than up a ladder. Meanwhile, screws are used to raise something or fasten 2 things together. There are large screws, like drilling rigs for oil, or smaller ones, like the ones you use to build furniture. Engineers design with simple machines in order to make work easier. This is called a mechanical advantage since it allows us to complete tasks easier. Sometimes there's a trade-off, though. For example, inclined planes do make it easier to traverse to higher or lower levels, but it'll take a little longer to do so because it's a longer distance. A ladder can get you up somewhere faster, but it's a little harder to use, especially if you're carrying something. Did you know that the mechanical advantage can be calculated mathematically? The mechanical advantage of a machine is the ratio of the load to the applied force, or how much force we need in order to complete a task. So, mechanical advantage, or MA, equals load divided by applied force. A good mechanical advantage is higher than 1. A screw is a simple machine that gives you a mechanical advantage as well, and it's pretty similar to the inclined plane. It's essentially an inclined plane wrapped around a rod in a spiral, sort of like a spiral staircase, which could be considered a mixture of a screw and an inclined plane as well. A screw also needs a lever in order to work properly, like a screwdriver, so you can twist it into pieces of wood to hold them together, for example. Not only that, but the screw could also act as a wedge, since it separates material as it's turned. But unlike a wedge, a screw must be twisted instead of being pushed straight in. A screw has elements of other simple machines, but is still its own simple machine. Drilling rigs, car jacks, and fastener screws are all examples of a screw. Screws typically have 2 purposes. They can fasten 2 or more objects together, or they can be used to help lift up a heavy object. One of the most famous examples of a screw used for lifting is the Archimedes screw, invented over 2,000 years ago to raise water from one level to another for irrigation. Engineers today use similar screw designs to move water, oil, or dirt in modern systems like drilling rigs or pumps. The pitch of a screw is the distance between adjacent threads on the screw, so the example here. This can be calculated by dividing the distance by the number of threads on a screw. For example, if you have a screw with 5 threads over an inch of the screw, then the pitch is 1/5. 1 full revolution of a screw into an object is equal to the distance of a pitch of a screw. So, with our example, 1 turn of the screw would move the screw 1/5 of an inch. Did you know that you can find the ideal mechanical advantage of a screw? You can do this by dividing the circumference of the lever by the pitch of the screw. The circumference can be found by multiplying 2 pi times L, which is the length here. So, the circumference would be 4 times 2 times pi, which equals about 25. Then, we divide 25 by p, or 1/5, to find the ideal mechanical advantage of this screw. Our ideal mechanical advantage for this situation is roughly 126. If we use a smaller lever, the ideal mechanical advantage decreases. If we look at the same screw with a 1/5 pitch, but use a 1-inch screwdriver, the ideal mechanical advantage becomes 2 times pi times 1 divided by 1/5, or 31. Let's go back to the inclined plane now. The greater the tilt of the inclined plane, the faster something will slide down it. This is measured by the angle of inclination. We can't forget about friction, though. Friction gives resistance when one object is in contact with another, so something can't slide forever. Take a look at this cube. It's on a flat surface with no inclination. In order for an object to stay in place, the force you apply to it would need to equal the same downward force as gravity. This is an example of balanced forces. However, if we tilt this plane, the cube will start moving downwards along the slope. This is because the force of gravity, or weight, is acting upon the cube in a downwards direction, so it slides downwards. The greater the angle of inclination, the steeper the slope, and the harder it is to push something up it. You have to exceed the force of gravity in order to push an object upwards. Did you know that you can find the ideal mechanical advantage of an inclined plane mathematically, just like we did with the screw? The equation for this is the length of the slope divided by the height of the plane. For example, if you have a ramp with a slope length of 20 meters and a height of 5 meters, then your mechanical advantage is 4. Today, we learned about the two simple machines called the inclined plane and the screw. Can you think of any of these simple machines that you can see in your daily life? What are they used for? What can you use them for? Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the TeachEngineering website. Then, check your knowledge of inclined planes and the angle of inclination in Watch It Slide.